Alrighty. So for those of you who are here, welcome. We are so excited to bring this decal to you guys. It's been in the works for a really long time, and we're ready to get this thing rolling and really show you guys what cloud computing is all about. So a few more people to come in, but let's see here. Can we get attendance points even if we are watching asynchronous lectures? We will be able to offer that just for uh, accessibility purposes and accommodations. We'll finalize that for by next week. So stay tuned. All right, so let's get started. Cool. Okay, so we're just gonna go a brief overview of course policies just to let you guys know what the course is gonna look like and what you can expect and what you should be prepared for. So our agenda for today, we're just gonna do a brief overview of class information, what information that we have finalized right now, and then we will update you next week on the entire thing and the whole spiel, so you'll be able to keep in the know. Next thing we're gonna do are we're gonna understand why we want to do cloud computing. So this is just another component we want to focus on. So understanding the cloud and understanding why we need to do the cloud as an introduction. And then last but not least, we're gonna talk about software essentials. So these are the things that you want to be able to know and download beforehand on next week's lecture in order to excel in the class. And we'll be able to guide you through the process for all of this. Another question? No, okay, sounds good. All right. So welcome to cloud computing. You might have seen this acronym CLAC across the slides and maybe even on our website. So what does CLAC mean or CLAC mean? Well, this decal is actually a derivative of the Cloud at California club here on campus. So unfortunately, applications for that have closed, but you can always apply next semester. But Cloud at California is our on-campus cloud consulting and education club. We are part of the education branch, and this is our first semester, at least with our team, to be able to bring this decal to you guys and to give you guys the essential skills you need to be a cloud developer. So we are very excited to have you guys, like very excited. And you might see this crab scattered throughout all the lectures. This is our mascot. We just call him the crab, something to make the characteristics of the club a little bit more interesting. Cool. So a brief introduction. Hi, my name is Bowen Fan. This is my first year lecturing at all. I've never been a TA, never been a GSI. I'm a third year EECS major, and I've been with the Cloud at Cal Club for a few semesters now. So this is my first opportunity to bring you a curriculum and to be able to help contribute to your cloud computing education. And I will go ahead and pass it on to Kathan, our education lead.
Yeah, hi everyone. I'm really excited to meet all of you. My name's Kathan. You've probably been receiving a lot of emails from me as I'm figuring out how to run this decal. But I am the education lead for our decal team, and this is my third semester as a part of Cal. Currently, I'm not in person on campus. So I will be joining remotely. And if you have any questions in the chat during the lecture, you can definitely send them to me and I'll try to get you an answer as fast as possible. You can also reach out to me over email, or you could also reach out to our decal email, which I recently created to improve the communication process.
Fantastic. And Shrita, did you want to give a brief introduction as well?
Yeah, sorry, we're still trying to figure stuff out. Sorry.
Oh yeah, no worries.
I could just do like a brief overview. So I'm Shrita. I'm going to be a reader for the decal this semester. I'm a sophomore studying data science and economics, and I've been in CLAC since freshman year, first semester. I started off as a student and was a researcher the semester after, and now I'm going to be helping out with the decal this semester. So I'm super excited.
Fantastic. Yeah, and then our other two readers slash TAs, Rahul and Justin, I don't think they are here right now, but they'll be the ones in charge of creating the assignments, kind of helping with the grading and answering questions. And then for all the, excuse me, for all those that just came and joined in, we're just giving out introductions right now, but apologies so much for all the logistical issues that we've been facing. I was unfortunately hit with a little bit of sickness. Was feeling under the weather, so I didn't want to risk going into person. But hopefully we can accommodate through Zoom, and we'll figure something out to make sure everybody gets the credit and the participation points. All right, and these are also going to be recorded and posted to B courses soon. So, all right, yeah, this is our team. You can feel free to reach out. We'll add our emails to the slides at the end, and then you can feel free to reach out if you have any questions about the club, the decal, or any general help. We're always available, and we'll set up office hours as well. Cool. Now, let's talk about our syllabus. We have not posted that yet. We're almost done. We're polishing it, but let me give you a brief overview of the syllabus. So we have the core staff information. It's a 2-unit decal, right? And our meeting times are going to be 6:30 to 8:30 in person in Corey 277, excluding today. So you should expect to come in person after this meeting and thereafter. So of course, quick overview of the course. We're just going to be teaching about cloud computing as a whole. It's going to give you the opportunity to work on some projects that you can put on your resumes to really, flex to the recruiters your cloud computing knowledge. And we're going to be focusing on multiple technologies within that. Some of your prerequisites, we would appreciate if you have some kind of experience in coding. It's not an essential, but we'll be able to help out if you don't. But things like 61A, Data 8, any type of programming environment that you've worked in, that would greatly help since we're going to be working with that a lot. Grading, this is a PNP class, so you shouldn't be too worried about failing or not failing the class. Like we'll make sure that we're doing the best to make sure everybody passes. You shouldn't have to worry about this part, but here's just a rough outline of what you can expect. Anything from, I believe, C or D and above is a P, and then F is a NP. So that's that. We have participation, homeworks, labs, and the final project, which we'll get into pretty soon. Assignment, we're going to be using B courses, and also Gradescope. We'll keep you updated on this. We're going to finalize that. And then here's our rough outline of what we're planning on teaching each week. Today, we're going to be going over software essentials, as you might already know, and then we're going to be exploring everything up to databases and even networking. So there's a lot of content for you guys. So very excited to bring that. Course policies are your typical course policies. Feel comfortable in the class. If you have some issues, let us know. And as always, try to avoid plagiarism and be legitimate. If you have any problems, feel free to contact us. We're students as well, we understand, and we'll be able to help you out. So students are allowed 3 absences. 1 can be unexcused and the rest are excused absences. You can email us 12 hours beforehand, let us know what's going on. We'll understand and we'll figure something out. Attendance, we'll be able to really be lenient on that. We're probably going to open up opportunities for you to watch recordings and do like a reflection on your own and submit that for participation credit in case you can't come in person. But like I said, we'll get that information all finalized to you by next week. Collaboration. So in this semester, you're going to be able to work on a final project. This is going to include a team of a few people. So this is going to be a main component of the 30% of your grade. It's going to be fun, and we'll guide you along the process, so there's nothing to worry about. It'll take from 4 to 5 weeks, and it's going to be split among those weeks. So you'll be able to know every part of the process. No stress on that part. And yeah, pretty much plagiarism, no plagiarism, please. Feedback. Yeah, as you know, this is my first year teaching. I'm always going to need that feedback, and I need to be able to give you guys good content. So anything or everything, let me know. And then accommodations, we'll talk about that later, such as posting these recordings. But cool, let's see, the answers are cool. Looks like Kathan is answering those questions. Alrighty, when we post the Google Slides, you'll be able to have the lecture, the syllabus link right here. So there we go, cool. So resources, B courses, that is gonna be our main essential classroom per se. We're gonna have lectures. We're gonna be recording through Zoom. And if you can't show up in person, we'll have the Zoom option as well. And we have YouTube that we're probably gonna be uploading the videos to. And our method of communication, we wanna get your guys' idea, because this is not your traditional class. We don't use, Piazza. And we're not sure if we want to use Ed, if that's like a preference from you guys. So I'm gonna go ahead and actually do a poll, and we will see whether you guys have a preference in terms of how you guys want to be communicated. So let's relaunch a poll. I'm gonna leave it out for like 30 minutes or 30 seconds, and we'll get some answers. Really appreciate the core stuff if we are allowed to watch async recordings. Perfect, that's good to know. Yeah, we'll make sure. Because students are busy, we understand. So things happen. All right. So it looks like 26% Slack, Discord 29, Ed 44. Okay, that makes sense. I guess for the sake of continuity and and standards, like we'll probably create an Ed, because I know for a lot of STEM classes, they're actually switching over to Ed after, Piazza was, taken away through the license. All right, yeah, course assignments. This is what you would expect throughout the course. We have 2-hour lectures in person. We have labs. They're not going to be every week, don't worry, but you'll have quite a bit of time to work on labs. There's not going to be sections, so you're not going to show up like a typical physics class or a STEM class where you need to come in person to do the labs. This is all on your own free will and your own time, so you have flexibility like that. We'll figure out office hours for you to get help from us and the TAs. Homework, we're going to have B course quizzes. We have quiz questions, and we also have short answers depending on what the topic is that week. As we're just mainly looking for completion and effort on your part. So we are that for the short answers at least. And then the quiz, we're looking for how well you know the material, but the material should be in the slides, so you have nothing to worry about. And then retouching on the project, you're gonna have the 4 to 5 weeks to work on that project, which is plenty of time. You're not gonna be bombarded with this project when you're studying for your finals or things like that. We'll be able to space it out for you guys. Cool. And yeah, a part of it is you're actually going to present your project. So that's going to be awesome. You're going to be able to present it to the class, teach the class the technologies you've used, and also be able to put that on your resume, which I think is pretty cool. Cool. And then this is like typically what you would expect in a typical week. Sorry, that was redundant, but as a student, you might be able to work on the lab, 3 times a week for an hour, and then do the homework for an hour and attend lecture. But this is all subject to how efficient you are and how you like to work. So, this might be 20 minutes, this might be 2 hours. So all subject to change, but we'll make sure it's not too hard. Student expectations, typical student expectations. As long as you're warm, welcoming, and have a willingness to learn, that's all we expect. If there's any issues, you can always contact us, and be honest. Don't plagiarize. It's not fun. I've been there, I've done that, sadly, and I face the consequences. So yeah, don't do that. And we're trying to create this environment of openness. Since this is a decal of 100 students, it's going to be tighter. So we want to be able to communicate with each other. And we will make an effort to do that as well. All right, and last but not least, we're just going to acknowledge some of the sources, education sources that we have pulled from. We took from a Cloud Guru, which is an online cloud education platform. You can check it out yourselves. It's really useful. And then we're also pulling from AWS documentation that you can find online in order to compile these resources and present to you these awesome slides. And these were also made from the education team from previous semesters. Alrighty, so software essentials. What do you need to excel in this class? What do you need to download? What do I need? Things like that. We're gonna go over all of that and give you a demo of everything. So first things first, Agile. This isn't really a physical software you need to download, nothing like that. This is a concept I want you to get familiar with as we start to move into that final project stage. So this is something to put in your back pocket. What Agile is, it's the name of a project management methodology. So you can think of it as a way you can keep track of your project from start to finish, every moving piece, every little task. And it's used in the industry, and you're going to be familiar with it if you join any project management roles or any software engineering roles. This is found throughout all of that. So let me get into some of the terminology. Yeah, Agile is the name of the entire methodology. So there's something called a sprint. A sprint is a interval of time within your grand scheme of things. Like it's like a section of your entire project that you're working on. That is what a sprint is. So sprints are typically, you have a new sprint every 1 to 2 weeks. And during the first day of the sprint, it's when you plan things, right? So this is the part where you're like, okay, these are the things we need to work on. Here are the bugs, or AKA like the stories, or these are the bugs that we need to fix. These are the people that are going to be delegated to work on those individual tasks and bugs. And that is what sprint planning is. You're delegating responsibilities and you're planning out what needs to be done. Typically in the middle of the sprint, you have something called a backlog grooming. This is the part where you're like, oh shoot, turns out these tasks are a little bit harder than I realized. We need to kind of maybe split up some of these tasks for more people, or you realize, oh, this might be a little too easy. We need to incorporate some more details into this task. That is what backlog grooming is. And last day, this is the reflection period. This is like, what have we done? What weren't we able to do, and what were we able to do? This is kind of saying, okay, this is what we didn't do correctly. This is what we did do correctly. What was the communication like? And this is just the reflection period on the last day of that cycle. And it's a rinse and repeat. You do that over and over again for a certain project. And after you do the project, you move on to another one. So that is what it's like in the industry when you're working in huge teams, right? You need some kind of standard to set. And then typically every day of the sprint, or every day, like when you're working in that team, you're doing something called a daily sync, or also known as a daily stand-up, or also known as a daily scrum. This is something that you might be introduced to in your internships as moving forward, or your actual roles. Is just basically, okay, number one, what did I do yesterday? What did I do the previous days? Like, what have I got done? Number two, what am I going to do today? And number three, what kind of issues am I facing? What kind of challenges do I need help with? And that's when you talk with your team and really kind of make sure everybody's on sync, hence the word daily sync. Yeah, and this graphic is pretty much a great way to visualize it. So to conclude, Agile, it's a word terminology to describe a glorified task list for a project. That is the main takeaway, and you'll be introduced to that more in your project. Next but not least, Git. You're going to be using Git. You might have been introduced to this already in your CS classes, or if not, I'll be able to provide a demo pretty soon. Git is essentially a version control. Version control, if you don't know what that is, it's like saving progress, right? And being able to make changes. And if you don't like the changes, you can go back to what you previously saved. So it's just saving your progress and building upon it, and being able to go back between different versions. This is also used in the industry. And some terminology, you have a repository, which is like a directory where you have these different versions. You have commit, which is like actually saving the progress, like it's like a checkpoint essentially. And then a branch is like the different paths or the different versions that you're creating out, which I'll get into. It's a little bit tricky, but and I'll go into these commands pretty soon. Yeah, for those of you who've already known about this, or you can kind of sit back and relax while I kind of give a brief overview. And then this is a cool diagram to kind of really visualize Git. Let's say you just created, I'm so bad with Pokemon, so please bear with me. Let's say you have this Pokemon and you took a snapshot of it. So that's what this is. You did a commit. So this is what the snapshot looks like. All right, you made another version of that Pokemon. It evolved. It turned into this. This is a branch. This is another branch, right? This is another version that derived from this. And then you keep extending the branch out. These are all the versions that followed from this version. And then you also have this other branch where it turned into a butterfly. You know, this is another branch that you could have took and built upon. So sorry if that's confusing. We'll get into that pretty soon, so you'll be able to see. GitHub. GitHub is essentially the online storage space, online storage service that stores all these versions. It's online, so it is also a form of cloud computing. So you'll be able to sync up with your private to public system. And then we'll get into the commands as well. But GitHub, Git, they work together, peanut butter and jelly. GitHub is where everything gets stored. Alrighty, I'm gonna skip this demo slide and talk about text editors, and then I'll do the demo. So what we're gonna be working with a lot this semester is we're gonna be using an IDE. So we'll get into text editors and IDEs and kind of distinguish both. Yeah, so text editors, what are text editors? Why do we need them? Text editors are anything that you can use to create or edit text. Microsoft Word, for example, is a text editor. Your Notes app on your phone, your iPhone, that's a text editor. You can write code in text editors and you can run code on text editor. It's crazy, but it's not optimal and it doesn't look pretty. That's where IDEs come into play. So it stands for Integrated Development Environment. It's complicated. I don't even know what that means, but one of the biggest distinguishing factors between an IDE and a text editor is IDEs can tell if your code is incorrect. IDEs can tell if there's issues in your logic, and it has pretty cool colors that you can customize. Whereas text editors, you write some wrong code, but your text editor is not going to tell you if it'll run or not. So we recommend that you download VS Code. Here's our tier list. You might have used Scratch back in like middle school or high school, but VS Code, we have it as the GOAT, and we'll give you links to download that. It's pretty cool. You have some pretty cool colors that you can work with. And then, yeah. Okay, so let me give you a brief demo. Let's see here. Right here. Okay, cool. Let me exit out of the slides. Alrighty. So right now, I'm going to be going on GitHub. This is the place where you store the commits, the files, etc. I'm going to create something called a repository. This is like the directory where you're holding all the different versions. Let's call it demo decal. Yeah, you would typically create your account right here, go to github.com, click create repository, and boom, it gives you some cool commands that you can run to set up your local environment that would be synced up with this. So right here. Oh, yes, okay. And then I'll show you, I'm gonna make a directory right now called demo, and then go into demo. And then I copy and pasted this command. Basically what it does, it just creates a repository, a Git repository on your own computer. And it'll have a connection between your own computer and the online service. So when you make changes on your computer and you want to upload those changes, you can do that. Cool. Nice, nice. Okay, so let me give you a little demo of how this is gonna work. Alrighty, let me grab my, okay. Yeah, so we're gonna create a file called, let's see, we'll call it cloud.py, something simple, not cloud.py, but cloud.py. This is VS Code. So this is actually a 3-in-1 demo. I'm showing you Git, GitHub, and VS Code. So it's pretty cool. So let's say I'm writing some code and I'm like, okay, print hello world. Oh my God. Please don't make fun of my typing speed. All right, hello world, right? Cool. Now you just made a version of the file, or you actually created a file and you edited the file. So you have a new version of something that didn't exist before. So that's something you could add as a separate version. So you can type in git status. This just tells you, oh, what are the new changes, right? So cloud.py, this is a new file, right? We can commit this, which means we can take a snapshot of it. Commit 1. Oh, sorry, I have to add it first, right? Sorry. And then commit 1. So this just took a snapshot of it. And this is a version we're holding in our local computer, and we can come back to it if we need to. All right, and then now I want to change up the code, and I actually say, oh, I don't want to say hello world. I want to say hello class. Whoa, you know, big difference. Now we check git status again. Oh, wow, it detected that we've modified the file. We need to take another snapshot of it if we want to save it, right? So we do the same thing. We do git add, and then we can do commit 2. Now we've just taken 2 snapshots. So we have 2 different versions that we have saved so far. We can say git status, and boom. It means that all our files are up to date, all our versions are saved. Alrighty. Now, let's say I want to create, I have an idea, right? Like, let's say I have an idea that I want to implement, but I'm not sure it'll work, but I just want to try, right? So I can do something called branching. This is something that's really cool. You can do something called git branch, which this is just like another test environment that you can do. A lot of software engineers, they use branching as a way of testing out code. So let's do git branch test. Let's say I want to test out another line of code. So like print 1 + 1 = 2, or 1 + 1 = 3. Let's say I'm really bad at math, and then git branch. Okay, okay, sounds good. All right. 1 + okay, yeah. So we have this new version of this code. We want to add it, and we want to take a screenshot or a snapshot.
Before you add it, make sure to switch the branch.
Oh yeah, right. So thank you, Katan. So we're gonna check out this. So checkout is switching to the other branch. So now we've switched to our new branch. Now we want to add, like, it'll detect like, oh, you have something that's been modified. Okay, we can commit that. New branch, cool. So now it took a snapshot of something we were testing, right? We have some version that we're not sure it'll work, but we want to, you know, give it a shot. So right here, this is our different version. So now let's say we want to go back to the old version. We realize, oh shoot, this really is not that good. Like this is not true at all. Like we want to go back to the previous version we have. We want to go back to our old branch or our old path that we were taking. So we can do something called switching back to our old branch. And then see, now it went back to that old version. We didn't even have to do that much. We just went back to it. And now we have 2 separate versions of the same file, but right now we're at the old version of it. So, and let's say, okay, you know what? I wanna take what I just wrote in that test file and I wanna just bring it over here just because. Like I wanna merge, I wanna take those two versions and merge them together. This, you might come across a scenario when you realize your new version is actually somewhat viable, but you're not sure, but you wanna at least bring it into your current implementation. So this is something called git merge test. Boom. Now you brought over the other version into your old version, and now this is your current version. It's pretty cool. And so when you look at git status, nothing happens because you just reverted back to a new version of this, or you went back to the old version and you added the test. And then this is to demonstrate what GitHub does. You can do git push. This is what syncs your local environment to the online environment. So now you go back to your online repository. Excuse me. Yeah, those are my projects from previous semesters. But yeah, look, you know all the snapshots you took? Now you can see it right here in this online place. Like, that's so cool. You're able to share your code and people can see your progress. And you can push whenever you have a new update to a file and everybody will be able to see it. Unless you make it private. But yeah, this is like what you'll see in class. Sounds good. And we'll go back to from the demo. We'll touch on that more. So yeah, go ahead.
Let's pause for a few questions because I think Git can be a bit of a confusing topic. And I see a question in chat. Currently, can you switch to the test branch? So can you go back and list the branches that are still active?
Yeah, which is the command for that? Is it git branch?
Git branch -v. Yep.
Okay, yeah. So that's a good question. You actually can. See, the test branch is still there. So you can actually check it out again. Git check out. And then what was the branch name? Test. So now you have this version. What is the following command that I should do, Kaplan?
For what?
I just checked out the new branch, so.
Oh, yeah. So you're on the test branch now, and I hope that basically answers your question, Osman. The branches, once you create them, they're always gonna be there unless you explicitly delete them. And branches and all your commits, they show up on GitHub. GitHub does a good job with their UI. So if you go back to GitHub,
Oops, excuse me.
yeah.
Let's see here. Wait. Oh my God. Sorry, I'm a bit of a noob.
Yeah. So yeah, if you click on, okay. You actually need to push every single branch.
Yeah, makes sense. So if I were to go git push. Oh, okay. It's no upstream branch.
Oh, you'll need you'll need a branch name to be able to push it to on GitHub as well. But basically the idea here is like each branch is going to persist unless you explicitly delete it. And you need to push every single branch to GitHub for it to be present on GitHub. And I see some questions about merge conflicts. Yes. So merge conflict, they're usually pretty tricky. We went over a simple scenario where Git auto merged it for us and there were no merge conflict issues. But in the case that you do run into a merge conflict, VS Code does a really good job of highlighting the old commit and the new commit when you're doing a merge between two different commits. and you can basically just choose one, and like VS Code will like do everything for you as long as you have the Git plugin for VS Code. I really love VS Code because you can always download all these different libraries and tools to make your code development experience even smoother. So if you're going to be working with Git, I definitely recommend getting the Git plugin. But I hope that kind of answers your question. If you want to be able to get like parts from both your commits, then you're gonna have to like manually determine the differences between the two commits and then choose based on your preference. Hopefully that answered your question.
Mhm. And then to clarify, the reason why before in the checkout, or sorry, in the test branch and in the main branch, they had the same version of the file. That's because we just merged them. So it's cool. Once you do a merge, you keep the branches, but in the branches, since you've merged them, now you have the same version of the file. So
Mhm.
it's cool. Once you do a merge, the branches
And
persist, but not the file.
can you also run git log? I just want to be able
Yeah.
to show them the commit history as well.
Whoops. Git log. Yeah, git log is hold on, I'm gonna switch back to, am I on chat maybe? Yeah, okay. Git log is like just like a history. You can kind of see what you've done and what you committed. So I just committed a commit with the message bruh and it persisted right here. So pretty cool. Nice. Alrighty. Hopefully that was an all right demo. I can make a nice polished one, a recording of it per se, if you guys would appreciate that, and we can set that up if it didn't make sense. But are we all good to go?
If you guys are okay and there's no more questions, can we get some reactions on Zoom? How about like a thumbs up? Like I just did it right now. So if everyone else is okay to move on.
Mhm. Shout out Connor. He has some good resources that he just. Cool. Nice. All right. If you have any more questions, we're always available after lecture as well. But moving on, we're going to talk about the cloud platform. So this is AWS. Like this is going to be the essential tool that we're going to be using. So we had some questions on, oh, this semester, are we going to be using Microsoft Azure versus AWS? For the sake of standardizing and like making sure everybody's on the same version of a cloud platform, we're going to be primarily focusing on AWS and teaching you the tools in AWS, but those skills are easily transported over to Microsoft Azure. And plus, AWS is the leading industry standard since it dominates about like 40% of the market versus Microsoft Azure, which is like 30. So you'll be able to kind of transfer over the knowledge. But here's a good like picture of like a dashboard. I can actually pull up the AWS dashboard as a demo. 1 second. Actually, I'll save that for the end since I think we're running a little bit short on time. But yeah, you'll be able to see your costs on AWS, your active services, what services you can use. And you have always this 24/7 customer support thing. They don't respond during those hours, but they can help you out. And for the sake of your projects, all the projects will be cost-free. So you have nothing to worry about on that. All right,
I just wanted to add a bit of a cautionary note. AWS is a third-party tool and we don't completely control it. We're going to warn you in appropriate places so that you don't end up doing something unexpected and then getting charged for it. In the case that you do get charged for something that you did on AWS, we will try to help you get reimbursed by talking with AWS as well. but we don't guarantee anything in case you do get charged. So it is a bit of an ominous sign, you could say, but I just hope we're on the same page with regards to any potential cost that you may face on AWS. If you are recently signing up for AWS, you will have a lot of benefits under the free tier that they offer for the first year that you have an account. So for the most part, we should be fine. But in the case that we do run into some exceptions and end up getting charged for it, we'll try to solve the problem, but we can't guarantee that you'll get reimbursed.
Facts. The funny anecdote story. I actually got charged like $43 because I didn't terminate my service when making a project for the cloud computing club. So it's always good to read the subscriptions and all that. But yeah, we'll make sure that doesn't happen though. We'll do our best to outline the steps. All right, we are good to go. Yeah. So these are some homework items, takeaways. So we don't have the B courses, what's it called? The enrollment codes out yet. So stay tuned for that. We'll send you an update by email. But if you don't have Git or GitHub, create an account on GitHub, install Git, install VS Code, not just a good text editor. I recommend installing VS Code and then create an AWS account. Most of you have already done that since in the application, we have an opportunity to do an Amazon S3 bucket with your image on it, or funny, silly images. Those are great, by the way. But yeah, create an AWS account if you haven't. Cool. Introduction to cloud. Finally, we're going to be talking about cloud, the whole purpose of this club, right? We're excited to bring this to you, and we hope you're excited as well. So we're going to teach you the what, where, when, how, why of cloud. So what is the cloud? So to put it into simple words, it's just basically the delivery of technology or resources across the internet. So you actually use the cloud every day in your daily lives. Like Zoom itself is hosted on cloud servers. So everything, all the hardware involved in running a meeting, all that's actually hosted on the cloud. Zoom actually partners with AWS to do that. So it's pretty cool. You use it like everywhere. And Google Drive and iCloud are like some of the common buzzwords or like typical examples of iCloud. So like Google Drive and iCloud, you think of storage, right? That is a huge cloud technology that made cloud popular to begin with. And one of the important aspects of it is that you don't need to own that much hardware in order to store that much data. Alrighty. And then, so I don't know if you guys remember, but back in like 2016, 2015, like there are some pretty cool Minecraft servers if you were on the wave at that time, like Mineplex, Hypixel. I might be throwing some mumbo jumbo that you might not know, but those were huge Minecraft servers, right? Super fun games. Like, anyways, yeah. So to run those servers, right, and to get that many users to log on and play together, that costs a lot of computational power. So if you were to do that on your own, let's say I wanted to host my own server and then have the entire Berkeley campus join it, you would see a fire truck across the street. Like it would be extinguishing the fire that started from my computer. Like that's how much computational power you need to host that kind of server. And not only that, I'd be broke because of my electricity bill. But now you have a solution, right? You can use the cloud. You can outsource that. You can outsource the storage, the server costs, all that to AWS. That's a really awesome solution. Now you can actually host these awesome servers for Minecraft users, high traffic, right? And everybody can have a good time. So we've talked about cloud as a storage service and as a server service. So that's just two pretty good examples of what you can use the cloud for, but we haven't even scratched the surface because there's some pretty insane things such as like API gateway and like Amazon Lambda, which we'll get into later. Those are some pretty cool services that you'll be able to experiment with. Yeah, Amazon Lambda, this is like something that'll handle computational power and run your functions. API Gateway, this is super good for performing API calls. A lot of industries use this. DynamoDB, this is like one of the biggest database skills you can learn. Like recruiters love to see DynamoDB on your resume somehow, because I don't know, it's pretty cool. I'll show you in a minute, in a few weeks. But yeah, these are just some examples, and you'll be able to learn a few of those and incorporate them into your projects. So 3 deployment models. So you have a cloud, right? What does that mean? Is that a public thing? Is that a private thing? Like, what constitutes a cloud? What does that mean? Like, what makes a cloud a cloud? So yeah, you have something that you can do on your private end, right? You can host it in your own environment. That's called a private cloud. I'm going out of order, but so if I were to create that Minecraft server and I wanted to run my hardware and everything, I've created something called a private cloud, right? People across the world can join on my server, accessing my private cloud. And that's something called done on premises. That's, you have control over the hardware and the resources yourself. Whereas if you wanted to do it and shift everything to AWS, that would be something called the public cloud. They would handle every aspect of the hardware, the security, the latency, all of that. That is the public cloud. And that's what a lot of businesses use when they're scaling up and they need more resources that they don't have on their own. They can't buy a lot of hardware all at once, so they move to the public cloud. So AWS, Azure. And hybrid, a little bit of both. Private cloud connects to the public cloud. So meaning you have a hybrid of both. You have services that interact with one another, some that are from your own environment and some that are in the cloud, in the public cloud. So those are your 3 deployment models. And we're going to talk about some of the real advantages of cloud computing. Like, why is it such an industry standard nowadays, and why do we care? You know, what is the purpose? Benefiting from massive economies of scale. So you could think of cloud as like cloud computing and AWS as like Costco, right? You as a customer at Costco, you're buying in bulk. You're buying a lot of things at once, and you're getting cheap deals for that. It's the same thing with AWS. You can draw parallels between that. AWS has so many things in bulk, and you as a customer or as a business, you can just use their services at a massive scale and save a lot of money. You don't have to spend a set amount for a certain resource, and you're not even getting the most out of it, right? You can go as you pay, and you're saving money along the way. And that's why Amazon has been really successful. They have dedicated so much of their revenue to actually create their cloud platform. And so that's why they're able to extend their resources across so many different areas of the world. Increased speed and agility. So you don't want to handle all the hardware, the computation on your own, right? You don't, that's a lot of work. That's what the cloud is there for. You can create your programs, run the programs all very quickly on AWS, for example, and you wouldn't have to worry about a single thing on your own. They have systems set up and tutorials available for you to actually perform those transactions. And that's really good. You know, if you have an idea, let's say you wanted to create a business, right? And you want a website to be hosted on AWS, and you want to have the database to be hosted on AWS, that's perfect. You use DynamoDB for the database, and then you use, I forgot which AWS service, but you can use the AWS service to host the website. That's awesome. You've just moved to the cloud like that, and that's one of the greatest benefits instead of building your own server. Next is stop guessing capacity. So coming to Cyber Monday, right? Websites like Newegg, Best Buy, Amazon, they get a lot of traffic. So many users are logging in to get those discounts, right? How do they prepare for all that traffic? How do they prepare so they don't have their websites like shut down or, you know, bug out because of all the traffic? That's something that AWS actually solves. stop guessing capacity means that you're actually able to do something called variable expense. So this means you're only paying for what you need, right? And you don't have to buy in for a certain period of time per se. So like, for example, AWS allows you to buy a service and pay as you go, whereas some other, you know, some other opportunities, you have to buy in bulk and say, you buy a service that can handle all the traffic for Black Friday, but you don't know how much traffic is going to be at Black Friday. So you're like, okay, I want to buy something that can handle up to this peak. Oh shoot, there's a lot more people than I believed. Now you're stuck with, oh shoot, I have to buy more resources for that. But AWS solves that. It'll optimize your costs and provide the service, so you're making sure that you can handle the peak. And that is what trading capital expense for variable expenses. You're being able to, instead of guessing how much you need to outsource and buy to handle your traffic, that's just one example, but handle your traffic, you can now pay as you go. And that, so yeah, general gist is pay as you go. You don't need to buy something that you don't need, right? That you're not going to use all of. And maintaining data centers, that costs a lot of money. Money bleeds running data centers. There's a lot of electricity here, a lot of cooling, a lot of refrigeration, and a lot of money paying those security guards that stand in the front of these. You don't need to do that if you can use AWS's data centers. They're pretty secure and they're reliable. You can go to the cloud and all your information will be safely secured in these hard drives and in these hardware essentials. So yeah, that's one of the biggest components of AWS at all, is like, you don't have to worry about the hardware itself. And it's pretty funny because there's actually been a lot of failed bombing attempts. I don't know which one specifically, but that's a pretty big attempt. Like, if you wanted to affect a lot of people at once, bombing like a data center, that's going to affect millions of people. So like, it's pretty important that you keep everything secure. And good thing those things are secure. And next thing is AWS is all across the globe. They have data center everywhere. So they have something called availability zones. So you're able to connect to these zones or use the services in these zones with very, very low latency. And then there are also something called edge locations, which are like, correct me if I'm wrong, but actually I'll let Kathan kind of chime in on that.
Yeah, so the way the AWS hierarchy is set up, you have, first of all, regions, which are mainly focused on continents or really big geographic regions. So the US would be one region, for example. I think Asia is another region, Africa is another region. So all these big geographic regions are also called AWS regions that AWS tries to serve. And then each region itself is going to have 2 or more availability zones. And what an availability zone is, it's essentially a redundant copy of a data center, right? So within a specific region, there's going to be multiple availability zones. And if for whatever reason one of those availability zones fails, then AWS will use the other availability zone as a backup to make sure everyone's operations are still occurring normally. And then in the meantime, they'll be able to fix the other availability zone that just went down for whatever reason. So availability zones create a nice redundancy for all your data, and it improves the availability and the durability of your data, which are some concepts that we will be covering shortly. And then edge locations, it's pretty different from regions and availability zones. What edge locations are is essentially a nearby location that is going to cache a lot of the data that you might be accessing regularly. If you look on the map, there's some pretty significant gap in the areas that AWS doesn't have the best coverage for. So what they'll do is actually set up an edge location in an area that doesn't have good coverage so that they can cache a lot of the content that you might be accessing. So let's say we're talking about like a streaming service or like a website that needs to be quick in action for different customers around the world, then you'll be using these edge locations to serve all your customers better and make sure they have a smooth experience. It'll ensure that they have low latency and really good connectivity and things like that. So that pretty much summarizes all of the AWS global infrastructure.
Thank you, Kata. Alrighty. Let's see. Okay, the cloud value proposition. We're going to talk about 4 main things. So, agility. You have the ability to move. This is kind of touched upon earlier in the slides, but yeah, try to keep these in the back of your pocket. The first term, agility, right? You're able to spin up your resources very quickly. You're able to go from idea to implementation faster. So you have an idea, want to build a website, host it, whatever, go to AWS. It'll handle all of that for you. And you're able to trial and error. And if it doesn't work out, it's fine. You didn't spend too much money or time doing something that didn't work out. You can do it again and again and again. No biggie, you know. Elasticity. So you can, this is also the pay as you go kind of model that I talked about earlier. You only pay for what you use. So that's really cost effective. Not only cost effective, but you're saving time not worrying about, oh, I need to plan for this traffic or I need to dedicate this amount of resources for this certain time where I'm expecting something. You know, you just pay as you go and you have a pool of money set aside for that purpose. And it works pretty well. They have pretty awesome algorithms to optimize your costs as well. So you're not getting ripped off. Durability, this just essentially means the service you're providing or the service that AWS is providing, you're going to get that service. Like what you would expect out of the service and what you're trying to do, it'll make sure it'll do it for you. So you're not going to have your data be messed with or nothing's going to be compromised. You're getting what you're paying for essentially, and they have made sure of that. And then security. Security is making sure your data is protected, making sure nobody has access to the data, and making sure no data gets lost. That's a pretty basic principle, but it's unbelievably strong. Like they have some pretty awesome protocols in place for that. So to recap, agility, elasticity, durability, and security. We might quiz on that. So make sure you review the slides and know the difference because there's confusion between agility and elasticity. You got to kind of understand those. Alrighty. Yeah, okay. We hit the last slide, sadly. But it's 7:44, so we did, you know, cut a little bit short, but that's fine since it's the first class and we can kind of work out some of the kinks and things like that. But here, I will attach the Google form. We're taking attendance by Google form for now, and I'll be able to confirm that next week. But
there's a QR code on the screen, so if you can just scan it using your camera and fill it out that way, that would also work. The secret word is Cumulus, as you can see on the slides. Even for the people that are watching the recording, you can fill out the attendance form using Cumulus as the secret word and submit it by let's just say before next lecture start. As long as you submit by then, you should be fine. And hopefully that answers any concerns that some people had earlier about attendance and being able to come to the decal remotely, things like that. You can always watch the recording and fill out the attendance form. Just make sure to do it before the next lecture starts.
Absolutely. Thank you guys for making it a comfortable environment for me to lecture. I'm still trying to get over, like some brief, I guess, like imposter syndrome about teaching the subject. So I really appreciate everybody's openness and willingness to ask questions. So I'm really excited. Hopefully I get to see you guys in person. And yeah, thank you so much.
If there's any questions, feel free to hang out with us and we can answer any questions for you. We did go over quite a few concepts today, so if you have any lingering questions, please let us know.
Hey all, just wanted to say amazing first lecture. I really appreciate it. And yeah, I'm super looking forward to this semester.
Thank you.
Thank you
That,
so
that
much.
keeps us going. That makes me happy. I'm going to bed all happy today. Thanks, guys.
Yeah, thanks.
Yeah, if you guys have any questions, we'll be sticking around. But other than that, have a great rest of your weekend.
Hi, Bowen. I really enjoyed the lecture today, and I find it pretty useful. I just have a question is that I didn't enroll the class before, and because I just dropped out from another class, I wonder if I can still enroll it.
Yeah, you should be able to enroll. We're going to send out the course codes today. And since you did show up to the lecture, we're gonna trust you to attend the decal regularly for the rest of the semester. So we'll be giving out codes to everyone who came to lecture today, including you.
Okay, thank you so much.
Yep. Okay, I see a lot of stuff in the chat. Hold on. Will the labs be individual ones or should we work in groups? Okay, that's a good question. I'm gonna say you should do the labs individually if possible, but if you need help, then you can come to us. The labs are a way for you to be able to practice the skills that you're learning in the lecture and actually use them and implement them in some sort of product. So you need to do the labs individually. You can discuss about it with your friends, but try not to get direct help from them because it's mainly a way for you to know that you're capable of working on AWS and using it for the purpose that the lab is meant for. And I'm sure you would like to work in groups as well. So for group work, we'll do the project in groups and you'll do the presentation in groups. And we're hoping you actually use the agile methodology while you're doing the project. So you'll get a chance to work in groups for the project. But the lab and the homework, please try to do it individually. And if you need help, obviously you can come to us. You can ask us over email, or you could ask us in lecture as well, after lecture is over. Yeah. Is this course a 3-unit course? Is it possible to make it 1 unit? This course is 2 units, actually. Once you're able to enroll in the course, you'll get 2 units, and it should show up on Cal Central, unless there's any technical difficulties. How many labs are we going to have this semester? Yeah, that's a good question. And we're still working on labs. We haven't done labs all the way to the end of the semester, But for now, I'm going to say all of our technical topic lectures are going to have a lab associated with it. Today, since we didn't really do anything super technical, there probably won't be a lab for today. So the short answer is you'll have maybe between 8 to 10 labs, and we have maybe like 13 weeks of classes or 12 weeks of classes. So you'll have labs like most of the time, but not all the time. We'll kind of space it out to make it um, pretty easy for you. And we'll do homeworks pretty much every week. I'm thinking this week, since it's our first week, maybe we keep it easy, but we're gonna do homework every week for sure, moving forward at least.